Hello, all my lovely friends, my math buddies. This is Mr. Kline. I'm going to teach you a little bit about solving exponential equations, and we're actually not going to be solving exponential inequalities. So let's mark that out, because we don't want to do any more than what we have to do, right? So we're going to be just solving some exponential equations, and some helpful things that you may want to remember from the olden days of when we were simplifying radicals is what your powers are. So if you see an 8, then you should be thinking, well, that is a 2 to the third. If you see a 64, then you should be thinking, hey, that could either be 8 squared, or that also could be a 4 to the third power, or that could also be a 2 to the sixth. Crazy, I know. But those are some helpful things you will want to remember. What we're going to have to do in order to solve these is we're going to rewrite each side of the equation with the same base. Once you do that, then you're going to be able to set your exponents equal to each other. So, for example, if we have 2x is equal to 2 to the 8th, 2 to the x equals 2 to the 8th, then notice how your x or your bases are the same. You have a 2 here, you have a 2 here. Then what that tells you is if your bases are the same, then this x must be equal to this 8, which would give you the solution of x equals 8. So let's look at our first example here. And if you have to solve each of these equations, notice we have a 3 to the power of 5x. And over here we have a 27 to the power of 2x minus 4. Unfortunately, they're not the same base, but we can rewrite each of these to have the same base. This 3 here, that's as low as you can go there. How low can you go? And over here you have a 27. That's not the lowest you can go with the 27. Keep in mind a 27 is a 3 to the third power. And outside here, we're still going to have this 2x minus 4. So now we have the same base. And when you have the same base, these basically just cancel each other out. Now, this cube is still here, and if you remember your rules for exponents, with your exponents out here, what do we have to do? This 3 and our 2x minus 4. Oh, multiplied, you say? Gosh, you are so smart. You are so smart. So we're going to take a 3 times 2x minus 4, and now we have an Algebra 1 problem, maybe pre-algebra, where we just simplify and solve for x. So we are going to distribute on the right. We're going to take this 3 times the 2x and 3 times the negative 4. That's going to end up giving us a 6x minus 12. And in order to solve for this x, I want to subtract this x to both sides. So let's go ahead and we'll subtract 6x. Subtract 6x, and that's going to end up giving us a negative 1x on the left. You don't have to write the 1, but I just did. Equals a negative 12, and if we divide both sides by a negative 1, that's just going to give us x is equal to 12. And that is your solution. So once we say x equals a positive 12, put a box around it, and you are golden. There you go. So now the same can be said for letter B. The 4 could be reduced. Okay, we could reduce that to a 2 squared, but do we need to? Okay, if we can remember a way to rewrite 256, it either has to be a base of 4 or it could be a base of 2. So easiest thing is if we can write it as a base of 4. Well, if I remember correctly, doesn't 4 to the 4th equal 256? If I remember correctly, and I do, then that's fantastic. So you have a 4 to the power of... Sorry about that little bell there. Forgot what I was doing. Where was that? So on the left, that doesn't change. On the right, this becomes a 4 to the power of 4. And so now your bases of 4 can cancel. And you get a 9n, oh, that's not blue, 9 n minus 2. That is equal to a 4. So then let's solve this for n. So we're going to add 2 to both sides. Add 2. And we end up getting 9n equals 6. We need to divide both sides by a 9. Now here, a 9er in there. And you get n equals a 6 over 9, which should be reduced, because all fractions need reduced, to a 2/3. Put a box around that, and bam, you are done. So I hope this helped you out with how to solve an exponential equation. Don't worry, there's probably more examples coming after this one.